chain me on the same page. We are effortless, schemaless, living in the future. You and me, made for us, serverless, living in the future of the clouds.
Well, it looks like we're out there.
Hello, good morning, good afternoon, or good evening. Thanks for joining.
We've
Um,
got a black screen though,
my
Rags.
name my name is Raghavan Srinivas,
Oh,
and
yeah.
just to make sure that we can hear only two voices actually. Aaron, do you want to talk and say something so that?
Yeah. Hey, everyone. Sorry for the technical details here. Um, but it sounds like yeah, I think we're both on pretty good here.
Are,
Um, looks like yeah, Rags, I see the Menti
yeah, yeah.
thing right now.
So do you want to bring up the presentation while I look for it in a second, if you don't mind, and then we can kind
Yeah,
of.
you know what? Let me why don't I share my screen, huh?
Okay, that's
Yeah.
wonderful.
We'll do it that
Yeah,
way. And if we run that,
perfect. I think it's looking great. I'm just gonna adjust the moons a little bit, and we should be
oh
good to
yeah,
go.
okay. I see us out there.
Yep. All right, I'll adjust that. But again, thanks for being patient and um, kind of staying with us. This happens every now and then. It's always fun,
Yeah,
to
no
kind of
kidding.
resolve it. But as developers, we really like this. But again, if you don't mind putting in a thumbs up once again that you hear two voices and no more than two, that'll
Yeah.
be really, really appreciated.
Stefano mentioned too that he can hear both of us, so it sounds like we're
Okay,
okay.
great. All right. Okay, with that said, welcome to this edition of our workshop, every Wednesday workshop, which we try to do pretty regularly. Welcome again to this edition of Introduction to NoSQL. Um, we will, as most of our workshops, it's going to be hands-on. So you're going to be doing hands-on. You're going to be creating Astra, and then kind of working through it, or creating an Astra account, and then kind of working through it. And for those of you who have probably been on our workshops before, you know how we go through it. You just follow a GitHub link and go through the instructions. If you're falling behind, no big deal. If you want to go ahead, no
Yep.
big deal. All of those work. They're all pretty self-explanatory. So you can kind of do it on your own pace. But we mix it up with some fun as well, right? So we do the Menti part, and in the Menti, what we do is, we kind of ask you a few questions about, who you are, so that we know the audience that you're talking to. And then at the end, once you have kind of warmed up with Menti, we have a quiz where you have to answer a few questions, generally related to the workshop, and you have to answer fast and answer correct, and that'll give you an opportunity to win some swag. With that said, let's move on to the next line.
Yeah. I think we're ready to go here. So, Rags, why don't you introduce yourself there?
Perfect. Okay.
For those that don't know Rags.
Yeah. I don't know myself because, as you can see, I have three different identities on LinkedIn, on GitHub, and Twitter. But they're all kind of a little bit variation of Rags, because for some reason people around the world have a tough time pronouncing my name as Raghavan Srinivas. But I was a mechanical engineer by education, which just means that I like to see things move. And that is why I like these workshops, because you can see code in motion, so to say, right? I'm a big fan of the inner loop, where you do a lot of like, compile, profile, push it to the outer loop, and then fix it and kind of do this over and over again. I also come from the Kubernetes side of world. So, I like to, basically simplify the Kubernetes inner loop as well, which is a never-ending mission. With that said, one of my primary passion in life is to teach and communicate. I even teach in the Boston area, which is where I live, and also communicate because I like to see the twinkle in the in my peers' eyes as kind of understand and try to relieve some pain points and so on. So I think I've gone on for a little too much. Let's move on to Aaron.
Hey, I'm Aaron. I'm a developer advocate here at DataStax. In a former life, I worked a lot in a lot of the Fortune 50 top retailers. I worked for Grainger for a few years, worked for Target for a few years, built out distributed databases at very, very large scale. I'm a Cassandra MVP back from when we still had that program. Hey, I also host the Apache Cassandra Corner podcast. So if you're already using Cassandra and you have a great story about it, I'd love to talk to you. And I've also written a couple of books, including the latest edition of Mastering Apache Cassandra, as well as 7 NoSQL databases in a week. I wrote the chapters on Cassandra, Redis, and Neo4j. So that's enough about me. All right, but hey, in addition to Rags and I, there's a whole slew of folks behind us, helping us out with creating content, getting things out there. Particularly, I'm gonna circle around Stefano here with the mouse. I don't know if anyone could see that, but he's in the upper corner here. He just basically helped us get the stream going with some issues we were having with OBS. So anyway, Stefano, if you're out there, thank you.
Absolutely, yeah. It's really a village that makes this happen, because we realize there are so many aspects of development today that it's impossible for a couple of people to kind of do the whole thing. So we have
That's right.
different people with different skills that we tap into, and really it's your opportunity to take full advantage of this. So I'm sharing my slides, Aaron. So if you don't mind,
okay.
I will take over from this point. All right.
Sounds
Let's
good.
make sure that I have the right one here. Okay, so this is the agenda for today. We'll talk a little bit about how the workshop is organized, and kind of give you an idea of how the rest of the next 2 hours is going to look like. Maybe a little bit. We might try to end in less than 2 hours if we can. Then we will talk about NoSQL, obviously, right? And we will also talk about the different APIs, because as a developer, I don't really care where my data is and so on. I mean, I do, but really it's the APIs that makes it easy to incorporate in applications. Okay, so we're going to do an introduction to NoSQL and all the different APIs, the tabular databases, document databases, key value databases, graph databases, and every now and then we will talk about SQL databases as well, and why NoSQL
A little bit,
a little bit, right? And why NoSQL is better to especially to build applications that are quote unquote cloud native, being able to scale, and so on and so forth. Okay. For those of you who attended our workshops again before, the drill pretty much. But again, we usually stream on both YouTube and Twitch. But today, since we've been having some technical issues, we are only streaming on YouTube. So it's probably okay, because most of our chat happens on YouTube. But if you're one of those Twitch fans, unfortunately for this workshop, you probably have to only use YouTube. If you want some long-lived conversation other than the YouTube chat, just go to Discord, and you can ask pretty much any question that you want, including some detailed questions on data modeling, how do you structure your data, or really anything you want on Discord. Okay. And of course, like I said before, we were going to do some Menti slides and kind of go through that. So with that said, let's move on to other resources that you can tap into. Obviously, our GitHub, and I'll show that in a moment. But if you go to github.com/datastacksdevs, you'll get a whole bunch of information in there. A whole bunch of repositories on just about every topic that you want to talk about. Like I think last week was AI, and Aaron, you, myself have done like a series on e-commerce workshops. I mean, on e-commerce.
Yeah.
We've also done something really, really interesting about kind of how do you detect long-term attacks using Quine and graph-based workshops. So it's not just DataStax. We have, every now and then partners joining as well. And the cool thing is most of these have nothing to install. I know Aaron is going to talk about graph databases, and that's probably not going to be like a hands-on part of it. So there is a little bit of installation that you have to go through. But most of our workshops have really nothing to install. Either you work in the ASTRA console, or use the ASTRA CLI, or better yet, you have the ASTRA CLI in Gitpod, and you'll see that in a second. Okay, so the intro to NoSQL, actually we give out a badge. So there is a homework, and we are not very tough graders, but we definitely grade. So we do look into your,
Yes, it's true.
your homework, and try to make it interesting, because we don't want to make it like a no-op to earn the badge. We want to make sure that there is some skin in the game to earn this badge. So with that said, we will point you at the homework and how you can earn the badge. It's not just the intro to NoSQL. There are a whole bunch of other badges as well. Pretty cool. Lot of people share it on LinkedIn.
LinkedIn is big for that. Yeah,
Exactly.
Yeah.
And you can also start earning these badges. You have to attend. You don't necessarily have to attend the workshop, right? You can complete the homework and still earn a badge, but.
Oh yeah, just by following the repo.
You could do that.
Yeah.
But most people at least attend the workshop and then submit the homework. One other question that we usually get about homework is, is there a timeline? Should we do it in like 2 days? Typically, we expect you to do it within a week, and we try to be responsive with the grading as well. Okay. With that said, let's move on to Menti. Okay, and I'm almost there.
All right. You have a lot of tabs open.
I know. I'm the multi-tab guy. All right. So let's do the presentation. Okay. Let me see if I can get this going. All right. So start the presentation. Come on. Okay. So you can see on the screen, it's 64915416. And let me start some music to kind of, have some fun here, right? Let me see. Where is that? Is there a music? Let me go with 2 small heads. And then the main monitor. Okay. And let me start the music.
I was hoping that doing the exclamation point Menti command would show the code, but let me put it in the chat.
I can do
here,
it.
just
Yeah,
everyone's got it.
It needs to be like an admin command. I can do that. Just give me a second.
You know what? I'm not in as my admin account. That's why.
Yeah, no worries. Let me put that in.
Yeah. All right.
And
I got
hopefully
it,
that
I got
works.
Yeah.
Okay. So again, the code is 64915416.
Yep.
Okay.
Cool. All right. I think we can. How
proceed.
many people do we have out here?
All right. Moving on.
See, 12.
Okay, you can use the QR code too if you want it. Okay.
That's a good idea.
64915416. We have a lot of people, so I'm hoping a few more can join. but if you didn't, you can join anytime anyway. All right, so let's move on.
Oh,
The first question we
right.
ask, and we love to see these dots pop up from everywhere in the world. Just put a dot. You don't have to be very precise. A few from India, quite a few from the US. Fantastic. Wow.
Oh, I think the first two in the U.S. were you and me.
No, I didn't join.
It looked like Minneapolis and
didn't
Boston.
join. Oh, Canada. We have a few from Canada. One from Russia.
Yeah, a few from India. All
Very
right.
cool.
Oh, Russia. There we go. Yeah.
Indonesia, as always, right? We do get one from Africa. If you want to put in a couple from Africa. Fantastic.
Some in like Seattle. That's cool.
A couple in Seattle. The three from Boston or something, or Raleigh maybe. I'm not quite sure. Hard to say.
The folks in Indonesia, I think we just had a Cassandra Day there.
Exactly. Yeah, we did.
Yeah, in Jakarta, right?
I believe we did. Yeah, I believe we did. Yeah.
it.
So this may be as a follow-on, or anyway. Thanks for coming.
Utah.
And let me move on to a few more questions here, and then we'll go to the. Have you ever been to any of our DataStax workshops? Okay, one person is in, 3 are in. Thanks for coming back, and as we expect, we do get a lot of first-timers.
A lot of new folks, and that's good. That's good.
Exactly. Fantastic. Oh, wow. This is pretty cool, because I don't think I've seen this before, where 2/3 are first-timers and 1/3 is like people who have attended more than, DataStax Devs Workshop before. Like I said before, we do this every Wednesday, and please tell your family and friends to join as well. What's your experience with, oh man, more than 5 years. We got to watch out for this person.
Yeah, that was me. Sorry.
That was you. Okay.
I skewed the results.
I got scared for a little bit. All right. This is kind of what we see, right? Typically less than a year, 1 to 3 years. We also have another person who's more than 5 years, which is kind of cool.
All right.
Nice mix here, right?
Mm-hmm.
So we have pretty much, again, about 2/3 of them never used, and about 1/3 have, different varying levels of experience. And I think it'll help everybody, including us, I guess, right? And if you find the quiz music a little too loud, let me know, and I'm going to be happy to adjust it. Okay. Have you used Apache Cassandra or ASTRA DB? Okay. Barely to never. So looks like, Aaron, you did not answer this question, right?
Yeah. I don't like to use the word expert, but yeah. I suppose if I've written a couple of books about it, I can probably do that safely.
Yeah.
Yeah. Okay. All right. Yeah.
So you put an expert. Okay. That's nice. I mean, you're being humble here. All right. Any thoughts before we move on, Aaron?
No, I think we're good. I think this is a good mix of people. So I think it'll be all right.
Let's go on to the presentation. All right. So okay, so we're done with Menti, but keep the tab or whatever open. If you're using mobile phone, it's probably the easiest. But again, don't answer in YouTube chat. This is going to be relevant for later. Just answer on Menti, and then we can kind of go from there. All right. With that said, Aaron, do you want to go?
Yeah. Reg, did you kill the music?
Let me kill the music. Thank you. Thanks for that. See, now you know.
All right.
Now you know what am I. All right. Yeah, I think the music is killed. So yeah, perfect. Keep going.
Yep. All right. Well, hey, let's start talking about NoSQL and how it differs from, well, SQL, I guess. So yeah, let's go ahead and get on that next slide there. All right. So for those of you who haven't used, a whole lot of databases before, like what is a database? Well, essentially it's an organized collection of related items. Typically it resides inside of a database management system. Although there are some databases out there that, have achieved some semi-mainstream use, which are really just a little more than file system libraries. But, for the most part, databases come with things like a way to interact with it. Like systems are built around like backups, maybe even replication if it's a distributed database. Access, you'll typically in the database world hear terms like RBAC or role-based access control. Those are things that you see in a full-fledged database management system. So, all right.
Give me a second.
Okay, so looking at databases by data model, or really, it's really a way of looking at databases in terms of like how the data is stored or laid out. In the earlier times, I'm talking like the 60s and 70s, we had things like hierarchical network databases. Even before that, there were really just like file system based databases. But the type of databases that really became popular, like from 1979 on, are relational databases. And relational databases all kind of started from a paper that E.F. Codd wrote while he was a consultant for IBM in 1970 called like, a shared data bank for, relational. I'm trying to remember exactly what it was called. But anyway, it was a paper that was written in 1970. And then finally, relational databases came about in like 78, 79 with Oracle version 2, I think was the first commercial database or relational database released. So essentially, the relational databases, had like a row-oriented storage method. They had, transactions around them, really designed for, like OLTP or, online transaction or transaction processing as opposed to like analytical processing, your OLAP. NoSQL databases kind of came about in the early 2000s, really stemmed from issues that we saw in the late 90s around, somebody would have a startup going, and they'd have a service that was on the internet, and they'd need data served to it. So what did they do? In the late 90s, they probably stood up like an open source MySQL instance behind a Tomcat internet server, and served data from that until they became really, really big and started to get too much traffic, which caused issues. So that's where NoSQL databases kind of came about to help out with that ability to scale to handle those larger traffic patterns. And you ended up with a few different types of NoSQL databases that came about. You had like your tabular or wide column stores, kind of like Cassandra and ASTRA DB. You had like your document-based databases that were like, typically schemaless. Typically it's just like the ability to define a record, kind of like JSON, where you can have certain properties in it or not. You also saw the advent of key value databases, which is really exactly like it sounds. It's really just, a value denoted by a key, and that's it. Redis is actually, one of the most popular databases out there, and Redis is like a key value store as well. And then of course, graph databases came about. And graph databases, like Neo4j, Janus Graph, DataStax Enterprise, they really took things from a different paradigm where graph databases became about that relationship first approach, about looking at the data entities with the same kind of on the same level with the relationships themselves. So yeah, it's a very, very different approach to working with your data, and being able to pull like hidden nuggets of data out of it is kind of the term used. So, talking about like multi-model databases, those are essentially databases that can do one or more of these, that can operate under a wide column or a document paradigm kind of at the same time. A popular database that does that would be, like you've ever worked with Azure Cosmos DB. That's one that does offer, you can do graph with Cosmos DB, you can do key value, you can do a document store with it. Yeah, it's very extensible, but the thing about the multi-model databases, it's kind of jack of all trades, master of none. I'm really more about choosing the best tool for the job, but yeah, we'll see. Regs, we can go to the next one, unless you want to jump in on that.
Go to the next one.
Oh,
Okay.
yeah. So, yeah, databases by deployment model.
Okay. Sorry. Yeah. Yeah.
Oh,
I'm having. Yeah.
yeah. Did we skip one? Oh, no. Okay. Yeah. So, really, we're talking about, the difference between like a database cluster, a cluster of several database server instances versus, like single machine databases. Your other deployment model you can have is like, you can have either like on-premise, most large enterprises have their own like, brick and mortar data centers that are kind of loaded up with servers. And then a lot of places are starting more and more to leverage the cloud. You look at Netflix. Netflix is known for their model of cloud only. Where Netflix is this huge company, but they don't own a single physical server. It's all out there in the cloud. It's definitely an interesting way to go in terms of looking at that sunk cost of purchasing hardware versus kind of just like borrowing it and paying a monthly fee for it.
Yeah, I think one other bullet item that we may want to add here is multi-cloud databases, right? I've created a
Yeah.
proof of concept for a Cassandra cluster which actually spans GKE and EKS. It's a proof of concept because I haven't really looked into the performance and latency issues and all that. But one of the things that I emphasize when you're using Cassandra, it comes in different shapes and forms, right? You can
Right.
kind of put it on-prem with DataStrex Enterprise or your own version of Apache Cassandra, or you can go to the other end, which is like in the cloud where we manage everything, and we're going to talk about that today, in Astra. But in the middle, there is something called as K-Sandra, which is K8 Sandra, which is based around, it's Cassandra on Kubernetes, where you can control a little bit, but also comes with, an easy way to be able to maintain Cassandra, because we have always heard this. Cassandra is great from a deployment perspective once you have it deployed. And, even managing it and all that is a little bit of a pain. Astra takes away everything. Cassandra actually takes away some things and lets you. So, so the database by deployment model is extremely relevant for those of you who are kind of thinking of switching from relational to NoSQL, but probably don't want to go to the cloud yet. But, so there are different options there.
Yep. All right. So, this is a good question. Why not relational? The thing is that, relational databases, they do have the benefit of like 40 years of computer science behind them. They're still very valid, still very relevant. You still get, you get that relational model. You get SQL, which has that relational algebra approach to, pulling data back. With SQL, with relational databases, things tend to be, what's known as normalized. Whoa, did that chop my fingers off? Can you actually see it? Yeah, you can kind of see it.
Chop the fingers off, yeah.
But normalization, if you look about it, if you think about it, it is really about optimizing your data for storage. Which if you think about it, when E.F. Codd first wrote his paper back in 1970, when Oracle was brand new in 1980, it's like storage was really, really expensive in those days. So it was really, relational databases are great, but they were kind of a product of the time. So the thing is, if you look at some of the places where NoSQL databases were engineered, to make up some of the corner cases that relational databases had problems with, it's like relational databases were originally designed to run on a single machine. And that gives them a few advantages in terms of like consistency and availability. However, it does make it more of a challenge to scale to meet demand. In fact, with relational databases, you can really only reliably scale vertically, which is really just adding more RAM, more disk, essentially more compute resources to that single machine. Um, so yeah, that's really kind of the main thing there. Why don't we jump to the next
Yeah,
slide here?
do you want to give them a sneak peek of ACID transactions? I know you and I were part of the Cassandra Day
Oh,
excitement that happened
right.
just last week, was it? And
Yeah, that was last
yeah,
week. Yeah.
and we were so thrilled to be part of the Cassandra Day. If you think about Cassandra, it's more than a decade old, but still a robust ecosystem. I think I will let Aaron talk about ACID transactions and maybe kind of give
Oh,
you a teaser on that.
yeah. So, one thing that relational databases have, and again, they can do this because of that single machine or single server design, is what's known as ACID transactions. So excuse me, you can have like database transactions that will span like maybe multiple tables if they're or doing multiple things, and you can see to it that those transactions are ACID, which is essentially atomic, isolated, consistent, and durable. Now the thing is that because of their distributed nature, NoSQL databases tend to have some issues around supporting ACID. So they can support like some of those things, but not really all of them, at least not all at once. But kind of the cool thing is that Apple has actually done a lot of work in engineering this addition to Cassandra, which will allow it to have distributed ACID transactions. So that is actually going to be really exciting and kind of a bit of a game changer for the Apache Cassandra project.
Mind blowing.
So
Yeah.
yeah. All right. So, we had one question of why not relational? Well, why NoSQL? Well, the big thing with NoSQL is really about, you know, high growth, handling, things that happen when your data gets really, really big, or when your throughput gets gets really bigger than your architecture can handle. So the idea there is that you can easily add more systems to your database cluster to help it scale to meet that either like pure data volume or traffic load as well. Um, so this graph here is just kind of like hey volume of data created and replicated worldwide. If you look in 2010 we just had 2 zettabytes, and today we're looking at 97, close to 100 zettabytes. So that's like a 20-fold multiplier over those years, over those 10 years, 12 years. So as you can see, we're just going to be having the more and more and more and more data, and you're going to see distributed solutions or distributed data stores like this really becoming more and more commonplace for sure.
I think we should have a Menti question about how many zeros in a zettabyte, right? I have no idea. So,
Yeah, that's a good point. I don't know. All right. So the origins of NoSQL, it's kind of a little bit of a buzzword, but really when you look at it, it comes down to being referred to as not only SQL or SQL, structured query language. There are some distributed or NoSQL databases which do support SQL, and then there are some that support like a subset of it. And then there are some that really just kind of have their own thing. So kind of like the generalization of those types of databases was it became NoSQL just as well. It's not only SQL. So there you go. All right, let's go to the next one. Okay. So What is NoSQL? Essentially, it's a database that can meet those high growth challenges. You'll see common characteristics. Although, I mean, at one point, I think there were some 400 different NoSQL databases out there, but they have some commonalities. One, it's that the data model, of course, tends to be non-relational. Because once you get into that distributed world, especially like in a large distributed database cluster, um, having those data relationships and maintaining them becomes very challenging. So of course, the data model that's used with distributed or NoSQL databases has adapted to that. And Rags and I are going to talk about that quite a bit because it is actually specific to like which database you're using. Again, I've talked a lot about having those data stores run on multiple server instances or clusters of database servers. The other thing you'll see too is that a lot of those databases are like geographically distributed, or in Cassandra's case, like geographically aware. And really, what that's about is if you have an app that's let's say like you have users on their phone on the East Coast and then some on the West Coast. You don't want your West Coast users making a call to the East Coast just to get their data and then waiting for it to come all the way back. You want that data to be local. You want to make sure that each of your users in a specific geographic area has their local data store, but you also want those data stores to be synchronized. So that's a role that NoSQL databases can play and are very good at. Again, we've talked about high throughput, high scalability. A lot of the NoSQL databases do tend to be open source. They really started to come about, and again, early 2000s, which was kind of like the same time as like the open source revolution, if you will. Where places did start to use more software that was freely and widely available and that you could change yourself, as opposed to going and dropping a whole lot of money on a proprietary enterprise license.
I think in Bellevue, Cassandra Day, we had a question from one of the attendees, and basically they were concerned about the fact that many of the open source projects are using something called as a business source license, which essentially means that it is not open source for a certain amount of time, like 3 years. Typically, that's how it kind of works. Right. I hope that Cassandra is not going to go to the BSL model, but you never know. The whole idea is that some of the cloud providers are using this and making more money out of the particular project than somebody who's maintaining it. So there is a lot of debate about it, but from a developer perspective, I'd like to see it open source. A typical open source license rather than like an Apache 2 or MIT, some kind of license like that, rather than a business source license. I don't want to. Right. I don't want to digress this discussion into licenses because, really as a developer, honestly, I just want to use it and I don't really care about licenses, right?
Yep. You just want it to work, right? Right. No, I get you. And that last point, bound by cap theorem. Really, if you think about it, all databases are kind of bound by cap theorem. Oh, sorry, we kind of jumped ahead a little there, but I'll just say that they're all bound by it, but they all adhere to different properties of it, and we'll talk about that in just a little bit here. But again, just to recap, relational versus non-relational. You have that standard relational model and query and a SQL query language. You have ACID transactions, designed for a single machine, which makes it harder to scale. Whereas, NoSQL, there's a variety of models and languages. You have that lower guarantee transaction, but you are able to get a higher performance out of that, especially at a larger scale. Designed to be distributed across multiple in a cluster. And you tend to have that that better database to app compatibility level. Again, just with kind of the way that distributed databases work, they tend to work in the same paradigm as like the microservices approach, if you will, on that.
So you may want to answer the question by Ashwin Raghunath. Is it true that Mongo now supports ACID?
Yeah. Oh yeah, I jumped out there in the chat. I don't think they do. Actually, I did my master's thesis on building out an e-commerce site on MongoDB, granted, this was 9 years ago now, but I actually ran two groups of competing transactions for the same record, and I was able to get it where like, half of them succeeded and then half of them didn't, and depending on when you looked at it, the value was one thing and the value was another, and so I was able to prove that Mongo doesn't have that isolation that that you'd typically see in ACID.
Is fair to say is it selectively transactional? No, I'm just kidding. You can just move on. Yeah.
I think now, if I remember right, there was a way to do it, but yeah, I'm trying to remember exactly what that was. So anyway.
but it's fair to say that most of these databases are obviously they are incrementally improving every day, right? So everybody recognizes that horizontal scaling is here to stay, but how can we kind of work around the cap theorem? So that's a nice segue into the next slide.
Right. So you may have been wondering what cap theorem is. I know we've mentioned it a couple of times. Essentially, cap theorem came out of a paper by Dr. Armando Fox and Dr. Eric Brewer called Harvest Yield and Scale of partition tolerant systems. I'm trying to remember the exact title of it, but essentially they postulated that, hey, all distributed systems try to achieve three properties of availability, consistency, and tolerance to network partitions. And then they kind of said, well, but realistically, they can only support two of those.
Especially in failure scenario, right? Especially in failure scenario, right? When there's a failure, then only two can manifest.
Then really you can only support two. Yeah, so that's where you kind of had these cap designations of, hey, a distributed system is CA, so it can support both consistency and availability, but not network partition. So really it's limited to a single machine.
Right.
Then you have like the CP databases that are consistent and partition tolerant. So they favor consistency and data distribution as well. And then you have AP systems where it's distributed and it's available, but well, it may or may not be consistent, at least not right away. And of course, if you go to the next slide, you can see that the different databases actually embrace different sides of that cap triangle a little differently. I'm seeing us. Okay. Oh, now we're okay. I was just seeing. I have our stream open in another window, and I just saw it like spin there for a little bit. So hopefully, we're all right.
That'll be good.
All right. So, anyway, so if you look at a CA system, that's where your relational databases are going to fall. So things like Postgres, Oracle, MS SQL Server, those are CA systems. You're looking at CP databases, that favor consistency but are also distributed. And that's where you're talking like, Mongo, Couchbase, Redis, HBase, kind of that way. And then on the AP side, databases that are distributed, that are highly available, that's where you have Cassandra, AstraDB, DynamoDB, DSE Graph. So so that's again that does tend to change with each NoSQL product. Each product, if you think about it, was designed for a specific purpose. So they actually will adhere to these cap properties a little bit differently. All right. So, hey, the one that we're going to use today is, and Regs and I have mentioned this a little bit, is AstraDB. So AstraDB is actually a database as a service. It is cloud only. So the cool thing is that it's serverless, scales on its own. It's totally maintenance and operation free. It actually runs multi-cloud, so you can deploy it in either GCP or AWS or Azure. Has a distributed multi-node cluster. It is NoSQL. It does have an API in it, which we'll talk about in a bit, that does kind of make it multi-model. But at its core, it is that wide column tabular Apache Cassandra underneath. So So yeah, so we'll use Astra to work through all of our exercises today. So on the next slide, if you take a look at you know, how Astra is kind of designed and what it offers, you can see that you have different ways to interface with it. And a lot of that happens because of that Stargate API layer that's in between there. Where you can send your traditional like CQL Cassandra query language commands. You can also get at it through RESTful calls over through the Swagger UI. Um, excuse me. GraphQL is also an option if you've used GraphQL before. Kind of as a way to aggregate multiple data sources. GraphQL actually is pretty cool, pretty up and coming. And then of course we've got gRPC. That's Google's new remote procedure call protocol. Does also go through Stargate as well. And then of course you can go ahead and still use the traditional delivered Cassandra drivers that are out there as well, for languages like Java. There's one for Node.js. There's one for C# in the .NET world. There's so yeah, Python of course is probably the most popular one, but yeah, multiple ways to work with Astra. All right. So speaking of Astra, we're going to talk a little through our first hands-on part here, which is really about just simply creating a new database, or if you've done this before, waking up a hibernating database. So Rags is going to take you through that.
Perfect. Aaron, I know that you've been talking quite a bit, so let me give you a little bit of rest. But this is a pretty easy part. What we're going to do is we're going to create the Astra credentials. Okay, so let me get out of Menti. And basically what you're going to do is you're going to click on the link, which takes you to, something that looks like this, right? Which is the Astra. ASTRA.datastacks.com. Okay. And then what you're going to do is you're going to sign in with GitHub, or you can sign in with Google, or you can use email as well. I'm using my email, which really, is fine. And I'm going to sign in. But if you don't have an account, you just, sign up and you can get started. Okay, so I signed in. So obviously I have already created a bunch of a bunch of databases and key spaces. Okay, and we'll see what this means in a second. And again, if you just put let me put this link here. Just put GitHub. I know there are a few questions that I'd love to answer, but let me finish this part. If you just do a GitHub, ban GitHub, it'll give you all the instructions. Okay, and that's exactly what I'm doing. I'm just going to go to that particular link. Okay, you can also go to github.com/datastacksdevs to look at all the repositories. But really, for today, I'm using this particular repository called Workshop Introduction to NoSQL. Okay. All that I do is just follow the instructions here. So it tells you register for a free account on Astra. So you're going to click this and you're going to create a database called Workshops and a key space called NoSQL 1. Please stick to Google Cloud Provider and then pick an unlocked region. The Monk's Corner is probably the easiest. But if you have already created one, maybe in a different region, it probably is still there. But if you don't, essentially you get $25 per month credit, which you can use to run significantly heavy production loads. Okay, so that it in itself is good enough, but it will not have high availability. So it does have high availability, but you can't do disaster recovery, multi-regions, a bunch of those things. For those, you will need, for a real production kind of workload, you will need to put in your credit card. But for this workshop, you're fine just using the free tier. And if you want more information on account creation, all that you're going to do is you're going to click on this. Okay, I'm just going to bring it up in a new window. Okay, and we'll kind of walk through this in a little bit. You can sign in with GitHub or sign in with Google, and then essentially, it talks about a whole bunch of things, but we don't need to worry about any of that. You can create a token, you can do the ASTRA CLI, but we're not going to, again, worry too much about that in this today's workshop. All that we need to do is create this database, okay, and I'll show you how to do that. Okay, if you go here, this is your ASTRA dashboard, if you will, right? And just say create database, okay? And now you can provide the database name, workshops, right? And what was the key space name is NoSQL 1. We also get a question which I try to preempt. What is a key space? It's basically a logical grouping of tables, okay? And we'll see all that in a second. So what I would love to do is see a couple of thumbs up of people who have already created this, like a database, workshops, key space, NoSQL 1. And, if you already have a database with the name of workshops, all that you're going to do is you're going to create a new key space, okay? And I'll show you how you can do that. Again, all that you're going to do is you're going to go to the dashboard, okay? And let's say you have workshops already in there, right? So let's look at databases.
Oh, look at that. You got a survey.
Okay, I have workshops, right? And I think you can either connect or you can create a key space there. Okay, so you can just say add key space, right? Add key space, and you can provide the, what is it, NoSQL 1, right? And I probably...
Yes, NoSQL and a number 1.
Yeah, thank you. Okay, and I probably already created this, so it's already in there, right? You can see here, right? And let's see a couple of thumbs up. Yeah, okay. We already seen a couple of thumbs up, so let's...
Yep, you have that one.
Shall we move on to the presentation? What do you want to do? I think that's all we needed in this. Now we can keep talking about the next part.
Yeah, is that it? Just creating your database in the NoSQL 1 key spaces,
so.
or key space. That's it.
Yeah.
Yeah,
Right.
I think you're right.
Yeah, wake up an existing hibernated database if it's already there, right? And to wake up the existing hibernated database,
Yep,
you can just
you're
do a
correct.
connect or
Correct.
anything like that, and you can wake it up. Okay. All right. Back to you, Aaron.
Yep, back to the slides. Okay, just making sure that we're on the same one here. So we've talked a lot about NoSQL databases, and we've talked a bit about like the types of them. So your tabular or wide column, that's typically your Cassandra, AstraDB, document databases. Again, you're looking at like Couchbase or MongoDB. Those are commonly used ones. Key value databases. I've mentioned Redis before. DynamoDB actually at its core is a key value database. Although there are ways to augment like other models on top of DynamoDB, but at its core, that's really what it is. And then of course you have your graph databases like DSE Graph and Janus Graph. Neo4j is probably the most popular one out there. Quine is another one that we'll look at a little bit later. It's not really a database, but it's more of like a real-time streaming graph, so to speak. But we can get into that a little bit later.
Streaming, pretty cool, right? Yeah.
Oh yeah. All right. So next slide. Hey, talk a little bit about Stargate. Regs, this slide is really cool looking. Nice job. I had a much simpler version of this, but yeah, yours, yeah, that's awesome. Stargate, it actually is an open source database API that we've built and is out there. You can really use it on top of multiple databases, but it comes along with AstraDB. So that's the advantage of working through Stargate. But anyway, let's have a look at a entity relationship model. So this example we're gonna use and show how to duplicate and how to work with it in different types of databases. That's kind of what we're going to look at for exercises today. So essentially, we have users, and users have things like names and email addresses, but users also have like 1 to n or multiple accounts. So user in a bank, so to speak, could have like a savings account and a checking account. They could also have a mortgage on their home, or some other kind of spending account. And those accounts are going to have properties as well, like, hey, what type of account am I? Or hey, what is my balance? And then you have examples on the bottom, like you have Alice and you have Bob, and Alice has checking and savings accounts. These accounts have balances. Bob, on the other hand, just has a checking account and has a balance of $1,000, euros. Yeah, something like that. So that's the example we're going to work with today. All right, so kind of looking at that relational data model. Again, if you're working with like a traditional relational database, like Postgres or something like that, the way that you would make that logical model work would be to build tables like this. So you'd have a users table that would have like specific data on just the users. Even have a user ID in there, and then you'd also have a table to represent the accounts. So here you'd have, your account ID, your, again, account type, checking or savings or whatever, the balance. But also that accounts table would likely have a foreign key of user ID so that it's easy to link it back over to the users table. And that's just one way that relational databases are kind of designed to, really kind of help you out model data that, favors relationships. All right. You can go to the next slide here. So basically, what about NoSQL? But like I said, this is going to be a simple one. We're going to look at how to go ahead and approach, solving or serving that data model in each of our databases coming up next year. All right, Regs, let's go to the next slide. Hey, there we go. All right. So one thing that that is going to help us out to work through a lot of those different paradigms is the Stargate API and how you work with it. So as AstraDB is Cassandra at its core, when we work with a like the tabular wide column model, we can actually go right through like the SQL console for these examples. But Stargate allows us to kind of work with those additional data models in a multi-model kind of a fashion. So when it comes to working with like document and a few of the other paradigms, we're going to be going through that Stargate API. I think today we're using REST, if I remember right, but yeah. All right, let's go on. And I think this next one is really just about back to the agenda, right? This next slide. Yep. So hey, tabular databases. Let's get started there. And jump to the next slide. Hey, there we go. All right. So tabular databases, it's essentially data that's similar to relational databases in the world where it is like a row-oriented approach to things. Where you have tables with columns and rows. Typically, though, in wide column stores, those tables will tend to be denormalized. And what does that mean? Well, it essentially means that you take that query-based modeling approach. So typically in the relational world, again, you're kind of optimizing for storage, and those tables can serve many queries. Well, in wide column tabular databases, you kind of flip that around. That's a different paradigm. It's, hey, I know what my queries are ahead of time, and I'm going to build tables to serve those queries. And the advantage there is that typically you can pull your data back just by hitting one physical machine or one logical machine, really. But the idea is not to have to make multiple network trips when you do a single query. Let's see. So, yeah, like I said, they have a lot of similarities to relational databases. A limited amount of like transactionability, but really, the use cases are, quite numerous, where you can have things like, Internet of Things, time series data, messaging, logging, content management. E-commerce is huge with wide column stores. So yeah, there's plenty of available use cases out there
Yeah,
for
I
sure.
think one of the things that hit me home when somebody told me, third normal form is not always required, right? is is when
Right?
you don't want to model your use cases based on your data. You really want to model the data based on the use cases, right? Which is really what NoSQL does. It optimizes
That's
for
right.
the use case.
That's right.
So if you keep that in mind, maybe you can do that with relational, but because relational is so strict on the third normal form, maybe you can relax it a little bit and still achieve some optimization there. But again, NoSQL basically is all about kind of optimizing for the use case.
Yep. That's right. That's right, Regs. I got to tell you, once I worked with an Oracle database that was in fifth normal form. That was a nightmare. That was an absolute nightmare. Basically, it's tables, but everything is a key. It just oh yeah. Sorry, that woke up part of my brain there that hasn't been active in 15
Yeah,
years.
yeah. I mean, normal form to this day gives me nightmares. Yeah. Yeah.
Oh,
Yeah,
I
but
know,
doesn't
I
mean
know.
that
So,
you should
talk
go willy nilly, and that's why you're going to be talking about data model. Data model is very critical. So there is a balance somewhere. Yeah.
So kind of sticking with that query-based modeling approach. When you look at this slide, you can see that we have accounts by user. So the idea is that we really want to query account data, but we really only want to pull it back by a specific user. So it's a good example of understanding what our query is ahead of time and then building that table, to kind of suit that query. So here you can see that we have user ID as our partition key, and user ID, or sorry, the partition key is actually what's going to be hashed, and then that'll determine where our data is stored, in the distributed database cluster. You can see this C up here for account ID means that it's a clustering key, and we're actually storing, or a clustering key. What that does is that actually determines the order of which the data is stored on disk within a partition. And that little up arrow there means it's stored in ascending order. Um, Kind of the other, things worth mentioning here too is that if you look on the bottom with well, I think it's username and user email. The S there means that those are static columns, which means that those values are actually stored with the partition, because otherwise you'd have to repeat them over and over and over again with all the rows. So it's really a kind of a
Optimizing.
little
Yeah.
bit of a space saving measure. Yep, yep. All right, we can go to the next slide here. So I briefly mentioned the partition key and how it helps determine where the rows are stored in the cluster. As you can see, the partition key is kind of like highlighted here. And actually, Regs, you can jump to the next slide already on this one. But what we're trying to show you here is essentially that key really determines which one of like the nodes in the cluster your data ends up on. And then based on how you have the replication factor set, you'll see that there will be like multiple of these stored. So a typical replication factor is 3. So really, in terms of like Alice's account on top here, this would be the primary, and then it would also be stored on like 2 neighboring nodes as like a secondary and tertiary replicas. So that's a so that's kind of a way that data gets distributed, inside Cassandra and other like wide column stores. All right. So as far as the driver architecture goes, really what the drivers are really good at, so when you connect to a Cassandra cluster or Astra, the driver actually reads the gossip information that gets passed from node to node. So it kind of knows which
Part of the
nodes are
control.
like, up and down, or yeah, like under resource restriction. And depending on how you build your connection, if you're using a token aware load balancing policy, the driver is actually smart enough to send the queries directly to the nodes that have the data. So that's actually important to note here. Now, if we jump to the next slide, there's a different way that Stargate will do it. So Stargate actually introduces a concept of like coordinator only nodes. And really what that is, that's a layer that kind of takes in that initial connection and then routes it based on where it's going. Kind of the advantage of that is having a simple way or a common port of entry into the cluster. That way, like if nodes go up and down, and change IPs, which again, in like a Kubernetes paradigm is going to happen all the time. That ingress layer actually, kind of gives you that common address or common entry point
Yeah,
into the
so one,
cluster.
one thing I talk
So,
about again in NoSQL databases in general is that, if you want to think about an oversimplified view of this, is it's like a distributed hash table. But the nice thing about that is you don't have to worry about replication, you don't have to worry about persistence. All of that is taken care of by the platform. And I think Aaron brought up an excellent point where, what happens if you bring in new nodes, what happens if the IP changes, all of that is, hidden. The platform takes care of that for you. So just wanted to put that in. All right. So again, Adam, you've been talking quite a bit. So let's go on to the hands-on.
yeah, go to an
Let's
exercise.
jump into the exercises. So we'll look at tabular databases. And again, all that you're going to do is go back to the GitHub link, right? If you don't have the GitHub link handy, just type in pound GitHub on the chat, and Nightbot will respond with the link. Just follow the link, and that should take you to right here. Okay. So let's go back to right there, which is right here. Okay, stay logged in. Okay. So let's go back to our GitHub link. Okay, again, you can, the other way of doing this is just go to github.com/datastacksdevs, and you can go to any repository there. But let's look at tabular databases, right? So what we're going to do here is we're going to go back to our dashboard, database dashboard, okay, and then click on workshops, okay, because that's the thing that we're interested in, and then do a SQL console, okay. So now, you can go in and kind of manipulate the database through SQL, which is our Cassandra query language, okay. So let's go there. So the first thing you're going to do is click on the dashboard, just easier to kind of start from there, right? And hopefully, you've already created the database and all that, right? And what happened to my workshop? Did I delete it? Well, there it is. I don't know what happened there for a moment. Okay.
Oh yeah, I know I saw you had it.
Interesting. Okay. Anyway, okay. So click on the SQL console. Okay. And then it does actually command completion and things like that. So if I just say describe, I just hit a tab, and it'll do all that for me. So describe key spaces. So you can see all the different key spaces here. Drop disk, here Spring, Stargate, to-do list, a whole bunch of key spaces in there. Okay, and then this is where again, we're going to follow the instructions, right? So I'm going to go back here. Okay, I described the key spaces. Now I'm going to create a table, which is called use, the NoSQL one, key space, and create a table under the key space of NoSQL one. Okay, so I'm just going to use this separately. Okay, so I'm going to use the NoSQL one. Use is basically saying I'm interested in this key space, right? And here what I can do is I can just say describe tables, because I've already probably created all of these. Okay, and you can see here, I have users by city, videos, whatever, right? And what I can do here is this was my old format. So what I'll do is I'll create this table, and always a good idea to and just for heck, I will drop the accounts by users because I just want to create a new one. Oh, there is no accounts by users. Perfect. Okay. So let me go in here and create this. So create the table. And basically, Aaron talked about this. User ID is my partition key, right? And so on. But again, you're going to follow the instructions. Okay. And you can see here I created a table. And now if I do a describe tables, this new table should be in there, right? So you can see here, I have everything here before, and in addition, I have this accounts by user that I just created. Okay, so you can kind of follow along, right? Oh, did I miss this part? So basically, I did not order by account ID, right? So okay.
Oh, it does
so
it automatically though.
That's cool.
So
Oh, that's right.
Yep.
By order ID.
I was going to mention that, but,
Oh wow!
it'll do it automatically if you
Okay.
forget it.
I didn't mean to. I didn't mean to do that, but yeah, I see exactly what you're saying. So what you can do, just to be clear, is you can describe the table, right? Let me do a clear so that it pops up to the top, and I can do a describe table. Accounts by users. Let's see what it says. And as they say, never do anything that you've not practiced before, but I like to live dangerously. Okay, and you can see here it's ordered, primary key is user ID, account ID. Did I really want that? I only wanted account ID, right? So what I'm going to do is I'm going to drop this table just in case, right? Accounts by user. I mean, this is not something,
Oh, actually, you do want that,
okay.
Rags.
Let me delete this, okay, and then I'm gonna do that the proper way so that let's do it
the proper way. Okay.
Okay, so this.
So yeah, when you specify a clustering key, if you don't specify a clustering order, it defaults to ascending.
Yeah.
Essentially,
Okay.
it's what it does there.
And this is not there, which is fine now, right? And Rags, make sure you paste everything, okay? So all that you're gonna do is you're gonna use this, and you're gonna paste it here.
Use
the copy icon
too in the upper right corner.
That might be the easiest way to do it, right? Okay. So now I'm gonna describe the table again, okay? And let's see what it says. Okay. Describe table accounts by user, okay? And you can see here the clustering order was account ID and not user ID. So that's kind of what I was telling you, Aaron, is that by default it used the user ID and the account ID, but really what we want is just the account ID, right? So yeah, okay. So just follow the instructions again. Use this cut and paste, and you're gonna be good to go. Now we're gonna do a create key space. Check the key space, describe key space. Let's do that. Okay. What am I doing here? Let me go back and describe the key space. Okay, copy that and look at that. Okay, and you'll see here a whole bunch of information on that. The thing you want to see here is clustering order by account ID. Primary key is user ID, account ID, and so on and so forth, right? So it has all the information in there. All right. So now we're going to do the create key space NoSQL with replication as network topology strategy. Okay. So
I don't know that we need to do that because I think that exists already.
Let's describe the table and take a look at that. Good point. If it's already there.
I think we could go right to 2C. Yeah.
What is the topology strategy? Yeah, I don't see that, but yeah, that's fine. So let me go to 2C, and again, you can always go back to this, right? So now what I'm going to do is I'm going
That's
to
right.
insert
Yeah.
into account per user, all of this. Okay, a whole bunch of information that I'm going to add here. Okay, so let me clear it again. And run this. Okay, and you'll see this is probably not a good idea to do a select star, and Aaron is going to mention why, but is that accounts from user or something? Accounts by user, whatever. Okay, describe tables and accounts by user, right? So accounts by, if only I can type, right?
Yeah. I think you did
Yeah,
accounts
so
from.
there you have the
There
user
you go.
ID, the account ID, and you can see the color tells you a little bit about this. What is the primary key, what is the order, that you use, clustering order, and so on. So you can get a whole lot of information just in the SQL console itself. Okay, and again, just follow along. Read by primary key. This is recommended because now it's going to go to that particular partition rather than go and search across the cluster, right? So I'm going to copy this,
That's right.
and I know
That's
that
right.
Aaron is going to talk about this a little bit more. So there you go. bobexample.org, right? It goes to that particular partition, and it's going to get the information on that. Okay, I think I've emphasized that more than enough. Okay, select where I'm doing from accounts by user, where user ID, right? Again, you're qualifying it and making sure it goes to a particular partition. Okay, so you can try all these queries yourself. Okay, and you will see here you have different account IDs, right? Accounts by user, where user ID is equal to so on, and it will get you that information. Okay, so try these queries yourself. But I think that is the end of tabular databases, really, right? Yeah.
Yeah, I think so. I think we're on
Document
to
databases.
document
Okay.
databases now.
So moving on. All right. Let's start the slideshow. So we're done with tabular databases. And Aaron, back to you.
All right. And let's see here. There we go. Yep. Moving on to document databases. You can go ahead to the next slide already. Kind of like we said before, examples of document databases are like MongoDB, Couchbase. Those are good, like good implementations of document databases. ASTRA also can work in a document paradigm. So we're gonna actually use that. Essentially, the main thing to think about with document databases is that they're semi-structured. I mentioned before that they're schemaless. They typically do care about things like an ID. So each document will have like a document ID. But the thing is that the documents themselves are not standardized within a collection. So you can have documents that have different properties from other documents that are in the collection. So it does kind of make it open to some specific use cases where not all records are going to be the same.
I think it's hard not to mention our colleague's name, Alex, when it comes to something like this, because he shudders at the thought of schemaless. Yeah, you
Yes,
would
do
rather
I.
you call it a schema flexible, right? Because there is some schema no matter what, right? So yeah.
Right. No, for sure. And despite what you may have heard from the marketing buzzwords, schema is a good thing. You do want schema. Yeah. But as we have with the example that you can see here in the lower right of the screen, we are going to use a RESTful approach to pull our data back from ASTRA here. So we can jump to the next slide.
And is it fair to say that data is stored as JSON in Astra?
I think it is. I think you're right. I know that like Mongo has their own type. They use it's like BSON, binary JSON, essentially. But yeah, I'm pretty sure that it's if it's not stored in it, it'll probably use the there's like a JSON abstraction inside of Cassandra where you can do select JSON and I actually get it in a JSON
Exactly.
format as opposed to a tabular. And I wonder if maybe it does that. But yeah, that could be. All right. So in looking at this, you can see that we have oh, this is for key value. Whoa.
It's
Oh no, it's not. Wow, somehow I got really far ahead and jumped on my
no.
my own slide deck here. So no, Rags, you are absolutely correct. All right, so the document model again going back to our bank account example, where we have Bob who has a checking account. Essentially, the way that's being stored is the data specific to Bob has its own properties, but accounts is like a list or collection or array really inside of the document, and that becomes more apparent when you look over at Alice's records, and you can see that Alice has her information there, but also inside the accounts array has multiples, so it has a checking account and a savings account. So really, again, that's just an example of how that data is going to be modeled a little bit differently, just depending on which database
Yeah,
paradigm you're
exactly
working
right.
with.
Otherwise this
Uh,
would all be like in a different accounts table, and then you have to join, the users to the accounts to really get information on Alice, who has both a checking and savings account. And typically, most of us have those accounts anyway, right? So it makes it a lot easier to just,
right.
put it in to satisfy those use cases. Yeah.
All right. So I think that takes us to the document database
So that was easy,
hands-on.
right? All right. Let's look at the document databases, and I think there are some exercises which kind of talks to kind of walks you through how you can see it in JSON and so on and so forth. Okay. So with that said, again, back to the GitHub link, right? Let me go back to the GitHub link. Okay, and all that I'm going to do is follow along, right? I've done with the um, partitions, right? Now I'm going to go into Cassandra. As you see, has native JSON support. Okay, and you can, if you click on this, it'll show you, insert into accounts by user. If you want to insert in JSON, you can do that. Okay, so let's try that. What the heck, right? So I'm going to insert into user by JSON. So in other words, we are going to make it very easy, right? If only.
Yeah, and that's the JSON keyword that I was referring to, when you asked the question about how is it stored. So yeah, I'm pretty sure it still follows the Cassandra storage engine paradigm, but you can use that JSON keyword to yeah, kind of put data in that way
Out that way.
and get
Yeah.
data out that way.
All right. So I've inserted in there, right? And you can select JSON, right? So you can basically say, I want the output as JSON, and you can see here, right? That's exactly what you're getting out. Okay. So let's see if it works. Okay. And again, where user ID, we are qualifying it to go to the partition, and basically now it's listing it as JSON. With the account type is savings, account balance is 8,500. Account type checking, the balance is 2,500, right? Again, I'm just showing this, but you can kind of do this yourself as well. Now, one of the cool things that we're going to look into is what is referred to as Swagger. Okay, and for those of you who haven't heard of Swagger, basically it's a open API. Now it's called Open API. It used to be called Swagger, but it's an open standard for using REST-based APIs. And typically with the REST-based API, you start with a token. You don't really need to create a token in this particular case, because what we're going to do is Stargate. I think Aaron talked about this. Actually, let me go small here. Give me a second here. Okay. Yeah, so that you can see the entire screen. And essentially what Stargate does is it auto generates the token. But if you want to use this ASTRA token, you can use that as well. Either of them works. For most of our other workshops, we prefer to use the ASTRA token, or we have to use the ASTRA token, but here you don't need to, okay? So there are examples, and I'm not gonna walk through all of this, where you can create an empty collection, you can create new documents, you can retrieve a document by its ID, you can retrieve a document in all the documents in a collection, you can search a document with a where class, and so on, okay? So I'm not gonna probably go through all of them, but I kind of give you an idea of how to use this, right? So how the heck do I use this? Again, go back to my instructions, right? I'm just trying to be like any of you, right? So what I'm gonna do is I'm gonna click on this connect tab, right? And just click on this connect tab, okay? And somewhere in this middle, you will have a launch Swagger UI, okay? So just launch the Swagger UI. Okay, and you have all the REST endpoints that you can play around with. So let's try to get all the namespaces. How do I get all the namespaces? Notice that there is a token which is automatically populated for me. And this is being done by Stargate, so I don't need to worry about this, okay? So I'm just gonna say, try it out, okay? And
that is an awesome feature of that automatic token injection. That's exactly. A huge time saver.
Except that I got a invalid clause. Is that what I got? Internal server.
Oh, did you hit execute?
Okay.
I think those are just example response. Yeah.
Always a challenge, right? Execute. Sorry. Yeah. Thank you. Yeah. So now it gives me the different key spaces. So what are the names? System traces. Some of these are system key spaces, if you will, and some of these are user key spaces. To-do list, and let's see if we can find the one that we created, right? Which is NoSQL.
Oh, yeah,
it's got to be in there somewhere. I should probably clean this up a little bit. It has so many of these, right? Because, there you go, the NoSQL one, right? So that's right in there.
All right.
You can follow along with some of these instructions, but it's pretty much the same format, right? So basically, this talks about V2 namespaces, namespace ID, and collection, right? So let's try that, and we'll provide a for the namespace ID, we're going to use NoSQL one, obviously, right? So let's try that. If only I can find that, right? Finding that is probably the biggest challenge here. Okay. So namespace ID collection. Okay. So namespace, and let me fold this. See if I can fold this. All right. Namespaces, namespace ID, and collections. Which one is that? That's always a challenge, right? Let's just do this. That's delete. I don't want to delete that. Get namespaces, right? All right, let's do this. And again, try it out, right? So here, we're going to put the namespace as NoSQL 1. All right? And now we're going to hit execute. And hopefully, this is going to give me all the namespaces, right? So where is it?
Oh yeah, I think it just gave you data back on the one namespace,
which is a US East one, and how many replicas are there, right? So you can kind of do a whole bunch of these. You can try all. We got the namespaces. You can look at the schemas, return all key spaces, and then you follow the key space name and tables. So let's try this, get the tables. Maybe this will work. Okay. And try it out. I'm just kind of doing it randomly. I probably should be a little bit more organized. But I'm in learning mode, right? So I execute this. Okay, and you'll see here, what are the different tables here, right? Videos, users by city. What did we create just now? Accounts by user, right? So all of this, you can kind of look through this yourself. But if you're writing an application, let's say, in Java or Python or whatever, you would use something very similar. You would call the appropriate REST endpoint and provide the token, and start using it, right? So you can see the different collections. You can create new documents. So let me see if I can create a new document. Namespace ID, collections, collection ID. Finding that is going to be fun, right? So go back to the Swagger UI. Okay, folders out.
Yeah, and
Yeah.
it's a
So
post,
it should be a
right?
post, right? Names. What is it?
I
Namespaces.
think so.
Go back. Kind of locate that. V2 namespaces. Okay. So V2 namespaces.
At least they have the
Exactly.
descriptions in there
Hey, is
too
this
of
a put?
creating. Yeah.
Right? Yeah. Let's see. Yeah. It's
Yes.
a post.
Or a post. It's a post. Yeah.
So namespace collections ID post. Yeah.
Yeah.
And we have multiple documents in there. So I'm going to go back to my instructions. You're going to hit the try it out button. You're going to provide NoSQL. You're going to provide the collection as users. And this is for the body, which is in the string. So let's try all that out. Okay. So again.
Yep. And then yeah, paste
So
that
let's do a
JSON
try it out.
into the
Right.
body then, right?
So let me first, do that. Okay, so that I don't forget. And namespace ID is NoSQL 1, right? And this
That's
is
right.
users. Hey, and I'm going to try to execute this. Right? Everything else should be fine. And let's see.
I think
we're good.
yeah, I
Let's
think you're
try that.
right.
Again, I don't think you're gonna hurt anything, and it's gonna come back. This is the command that was used, the curl command, if you will, which you can do from. Oh, it is a bad request. The payload
Yeah,
rate must be a
like
JSON
something.
array. Okay. So did I miss
Oh.
something over there?
Oh,
It
because
is
it's
a
a
JSON array.
batch. Oh, it's in JSON, but it's not an array. You know what? Just throw two
Okay.
square brackets around it, and then
Yeah.
that it'll go.
All
Yeah,
right.
yeah. Yeah, sometimes it's hard to find the right endpoint in there, but I think we can make I think we can make it work.
So essentially what I'm doing here is I'm altering the string, right? So
Yeah. So around yeah, right there. Just put square brackets around the whole thing basically. And I think that'll
we're
work.
gonna live dangerously. Okay, and let's see if we can execute this. There you go. We got back a document ID. Okay, so basically what it was required, I used a different endpoint which required a JSON, and essentially what we did was we JSONized the data, and we were able to create a document ID, and we can retrieve it.
Yep. Remember, folks, this is live, so sometimes
Exactly.
things happen.
But again, you can keep adding. You can see here, if you get the right endpoint, which is the namespace ID, collection ID, you can play around with this. I'm not going to beat this to death because find all documents by collection. So you can kind of look at this namespace ID, collection ID, and it will give you all the the document IDs and everything in the collection, right? And then you can search a document with a where clause, so you can pull out one, and then you can use that. But I'll leave it as as an exercise for you guys, because I know we are kind of reaching the end point of our workshop. So I'm not gonna beat this to death, but hopefully I kind of gave you an idea of how to use the Swagger UI and how to kind of invoke this respective endpoints, right? So essentially, you're gonna do this get, which basically gets you back. Post is post, as you can imagine. Delete is for deleting, and I believe there's a patch, which basically means update it, right? So update data at the root of the document. So you can kind of play around with this. We have provided some examples. but you can, for example, if you want to look through all the columns, you can do that. Kind of look at the schema. If you want to look at the data, you can do that. So a whole bunch of these. Feel free to kind of play around with it, and get some idea. But we will move on to the next part, right? All right.
Yep. All right. So I think next we're talking about key value databases.
Did I go back? Oh, there it is. Yeah. Yeah.
I think you're okay. Just keep going. Yep, right there. Perfect. All right. So, now we're going to talk about working in the the key value paradigm. Essentially it is just like it sounds. It's, you have values denoted by a key, and that's essentially it. It's limited in that each individual property or column that you might have in a row or a document is actually kind of split out on its own. But it's the thing about key value databases that they usually, because of their structure, can run more in memory, so they do tend to be very, very fast. So it's really great if you have a model that supports just simple key lookups. Again, serving content by key, that's usually the best approach.
Yeah.
You can go ahead to the
I want
the
to
next
take a
slide
moment
here.
to
So
answer Mridul's question.
look at that.
Mridul's question,
yeah.
is it possible to pull data using SQL driver in JSON format? And the answer is yes, correct? Yeah. I think, I don't know if I
Yes,
demonstrated that.
That's right.
But yes, absolutely. Okay. Moving on.
Yep.
Just give me a second. Yeah.
All right. So basically, when you start using a key value data model, when you have multiple properties or multiple values that are sort of related, what you end up doing, as you can see here, is kind of putting the column or property name as a part of the key itself, and that allows you to kind of model out some different scenarios. But the thing is, though, is that you kind of have to get each one of those values as its own read or as its own transaction. So that's really kind of the drawback there. Is it is a little more query heavy, but you can absolutely do complex models in a key value store if you're so inclined. All right. Well, I think that gets us to the key value exercises then.
And maybe what I'll do is I'll go through this really quickly, because I know you wanted to kind of show the graph databases, which is very cool, right? So looking at the time.
Yeah, I won't spend a lot of time on that
and,
either,
and
though.
We still have Menti to do. So let me go
Still
through
have
this
Menti,
very quickly.
yep.
Again, go back to the instructions, right? And key value databases, right? So I'm going to create a table called users key value, okay? Or user key value, whatever. Very simple.
Yep, very
right?
simple.
Exactly. Yeah. So I'm going to go back to my database, right? And I'm going to go to SQL console. Okay. And then let me see if it works. Okay. So I've created a table called users, so I can do a describe tables, right? And I can also do a describe tables users KV, right? Oh, what happened there? Describe table. Okay, so there you have, the key, what is the value? So it's basically a very simple key, and key is the primary and value is text. Okay, so you can get information on that. All right. So now I can populate the table. I'm not going to show you all that. Okay, but then what you can do is you can insert into and then select star where key is equal to account colon, right? So here you can see here I've qualified with user colon, account colon, and so on. and it will give me the expected value. Or alternative update syntax is you can set the value is equal to whatever, where key is equal to account. Just a different way of doing the same thing, right? And if I want all the information, select star from users key value. Again, probably not a good idea, but it's okay because we don't have anything in here anyway. But if I were to insert this, okay, let me go ahead and insert this, then you will see that you will get information on all of that, right? So let me clear this, and I will insert this, okay? And now if I do the select star, okay, select star, let me go back to the instructions. Just easier to do it that way, right? so if I, yeah, select
okay,
star,
but that's all right.
I can look into all the.
Oh yeah, they do have a specific. Oh, that's okay. That's okay. Sorry, I will not backseat drive, Rags. You
so
go
here's
ahead.
the account. Each of them is a key, and then the corresponding value associated with that. Okay, you can kind of again look through all of these, different queries here, but they're all pretty much variations of the same. Okay, so with that said, let's kind of move on. What do you think? Cool.
Yeah, I think that's good. I think we can move on.
Graph databases. Back to you, Aaron.
All right. So graph databases are really unique in the sense, and I kind of mentioned this already, in that they really do take like a relationship first approach. And data is actually kind of broken up into three classes. Where you have your data entities, sometimes called vertices. And then you have your relationships, which are sometimes called edges, and then you have properties. And this is true for most or all property graph databases, I should say. But that you can put properties on both the vertices and on the edges to really kind of expand out a lot of that functionality there. So yeah, there are a multitude of query languages out there. Gremlin and Cypher are far and away the most popular two. In fact, I think that they are actually the only two that are recognized by the by ANSI, the American National Standards Institute. There are, like I said, other query languages, but they tend to be specific to like a single product. Where there are many databases out there that allow you to use both Gremlin and Cypher. Use cases. This is one that's important, one that's often overlooked. Graph use cases tend to, like I said, focus on relationships, and relationship discovery is kind of the other thing there. So you might see it used in like customer 360 applications. Personalization or recommendation is another big one. Again, where you're talking about, let's say that Rags and I both like Star Wars. Well, if Rags is looking for another movie, the algorithm might leverage the fact that we both like Star Wars to go, oh, hey, Rags, Aaron also likes Blade Runner. You might enjoy that. And, it can make recommendations based on that graph traversal, essentially. And then Rags also mentioned fraud detection. That's another one that is really big in the graph database or the streaming graph world as well. And in fact, a few weeks ago, we did a workshop with one of our partners, Quine, about, using their real-time streaming-based graph that allows them to see like a lot of these patterns and anomalies as they're happening, and that's really what you need for things like fraud detection and intrusion detection, kind of there. So if we go to the next slide, you can see that keeping along with our data model of Bob and Alice and their bank accounts, you can see that the users and accounts are the data entities or vertices. And then we had this edge in there called has, so the users have an account or has account, and you can kind of see how those play out there. The account types and the balances, end up being properties. So yeah, that's really how it works. So for this next part, we're not going to have you do anything with graph databases. I'm just going to run a real quick demo for you to see here. And Rags, I'm going to share my screen.
Okay.
In just a second. Okay, you should see it coming through. And then, hey, all right. I think we're live. Huh?
Just give me one second. I'll make a small. Okay, I think you're good. Yeah, go ahead.
Oh, yep. Okay. Sorry, I tabbed out here. Oh, there we go. All right, I think we're back. Okay, so this is Quine. So I'm actually using it to kind of show, kind of as a graph visualizer, because that's what I think Quine does really, really well here. I don't really have a like a real time or a streaming use case, but in light of the Artemis mission taking us back to the moon, I thought I'd show a little bit about like the like a little bit of like the NASA assets. They're actually widely available out there as a data set. So I can do my Cypher query right in here. I can say match, and I'll say let's say that I want to know which astronauts flew on a certain mission and what universities those astronauts went to. So I could do something like S school. And that's going to be.
So you can do some pretty complex queries, with graph databases, right? Yeah.
Yes.
I mean, I can't even comprehend how I would do that in like a NoSQL or a relational world, right? I mean, traditional, right? You may have to do multiple joins, and I don't know.
Right. So this is actually going to show me like joining 3 different vertice types together here of school, astronaut, and then mission. So the astronauts flew on, that's the name of the relationship. And then the mission is, I'm going to key it off of the name property, and this is going to be Apollo 13.
Right the first time.
Oh, I know. Like I said, this is live, And if I do a return ASM, well, that should work too. Okay, so if I go ahead and run this, if I did everything right.
Wow.
Oh, look at that. It worked. Wow. Yeah, I must have typed everything exactly right here. So again, if I right click on that mission vertice, you can see that it's the mission of Apollo 13. If I go ahead and look at one of the astronaut nodes here, you can see that this is for Fred Hayes, who was the Apollo 13 lunar module pilot, which he never got to do because 13 was the only Apollo mission that, well, I should say after 11, it was like the only later one that actually missed the moon. That was kind of a mishap there. But if we look at the school vertice here, you can see that Fred Hayes went to the University of Oklahoma. And then likewise, we can look at some of the other astronauts who are also on Apollo 13. This is John Swigert Jr., who went by Jack, so Jack Swigert. And I believe he went to like U of Denver. Oh, University of Colorado. That was, so I was close. I was close. And then of course, most people when they think of Apollo 13, it's Jim Lovell who comes to mind. And I think Jim Lovell went to the U.S. Naval Academy. That's right. So again, this is just a little just a little taste of like what you can do with a graph database. Quine has this thing where you can like kind of animate it to turn the physics engine on, so it'll float around a little bit here too, which I don't know. I think is kind of cool looking. But yeah, you can kind of take this whole thing and move it around.
So
but, yeah. That's I think that's all we're going to do with graph databases today.
That this is all stored in Cassandra, and that dot, which is the company behind Quine, recommends doing
That's
the
right.
and if you want to take a look
That's right.
through SQL, you can do that by all means, and kind of look through all these properties and all that. But the nice thing about the query
Yep.
that Aaron did was kind of look at all these different relationships and come up with kind of how the real world looks, right? That's kind of how the real world is. You
Right.
want more information,
Right.
and I think graph databases are fantastic for something like this. Yeah.
No, for sure.
All right.
For sure.
So with that said, let's move on to the conclusion. And I'm gonna
Yep.
stop your screen share. And we have a few more slides to get through, and then we're gonna do the Menti, of course. So sharpen your
Menti, and then I
pencils
think we're
for
good,
the Menti. Be ready. Just try to recollect what we talked in the workshop, because we're gonna use that. Do you want to talk about this? Which database to use, and then we'll kind of go. Yeah.
Oh, that's it. Yeah, that's a great point, Rags. So a lot of times I get asked, what database should I use, or what type of database should I use? And really this image actually does kind of attempt to answer that question. It's like, hey, how much do you value relationships versus how much do you want to be able to scale? So in the relational world, you're really talking a high value in relationships, but you're basically, right on the line on that x-axis. The ability to scale is pretty much not there. We just talked about graph databases a few seconds ago. Traditionally, though, they don't scale very well, although there's a lot of advances happening. Again, with tools like Quine that are kind of pushing the bounds of how fast and how well you can scale a graph database. Traditionally, though, they're not as scalable as other types of databases, though. And then you start looking at things like document databases, wide column stores like Cassandra and ASTRA. Those are pretty easy to scale, but sometimes you'll want to have queries run against them that may not scale so well. So it really does more depend on what type of model you build. Whereas you look at key value stores, there's like no relationships, but by and large, you're limited to just single key queries, and that makes it super fast and super scalable. So really, again, it's kind of a XY axis as to where you want to be able to put your database.
So this is an old screen. That is not good. I think we missed this part. How do we do this?
Yeah. I tell you what, why don't you go ahead and run Menti, and then I'll fix who they're supposed to send it to.
This is why we do two at a time. It makes it easier. All right, let's run Menti. And I think you probably already have the code, but if you don't, basically it's 64915416. Okay, so go to menti.com and 64915416. Okay, and I'm going to present. Go into present mode. Okay, we saw this before. Okay, but now is the quiz part of it. Okay, and again, this is the code. You can use the QR code if you're just joining. Okay, 64915416. Okay, and we're good to go. All right. This is the quiz. Ready? All right. Start with first question. We have a few people still joining, so give it a little bit of time. Okay.
Yep.
This is always the fun part of it, right? And you will get some swag. We are able to ship it anywhere in the world, right? And let me add some music so that we'll have some little bit of fun with this. Okay, and let's see. What did I say? Music, right? Okay. All right. If it's too loud, let me know. I'll try to keep it down a little bit. Okay. So ready for number one, question number one. Answer fast, but most importantly, answer it correctly. What database should you choose for high growth applications? Is it a relational database? Is it NoSQL database? Is it a hierarchical database? Or is it an object database? All right, time's up. Wow, okay, everybody got it, except one. Yeah.
Hey, that's good. That's good.
There is a relational database fan is not going to jump off the wagon. But that's fine. Yeah. Okay, so let's see who's on the leaderboard. Chinmay answered the fastest. Mridul also was fastest. And it's a tie. I don't think I've seen a tie before. That is interesting.
That's that's got to be like down to the millisecond.
Wow, you guys are amazing. All right, but you know, even Jenny, Panda, who are at the bottom of the board, had a chance to kind of jump up. Okay, so let's move on to the next question. Question 2 of 7. You know, there are plenty of questions still to go. All right, answer fast, but again, answer correct. What is the most important benefit of most NoSQL databases? Faster joins, no need to design a database schema, is simpler to operate, better performance and scalability. A little sneaky, right? I don't know. A little.
Just a little.
All right, time's up. Okay. You still need to do a schema, right? You know, and that's why we emphasize that. It's not really completely schemaless, but it's flexible schema. The idea is that you don't need to be stuck to that schema forever. You can adapt it as you go along. Okay. But better performance and scalability is probably a little bit closer. Like I said, you know, we probably made this question a little bit harder than it should be. But let's see how the leaderboard is shaping. Unfortunately, Chinmay answered wrongly, I think. But again, you know, come back to our workshops. You still have a chance. Daniel Doan was the fastest. Maybe he didn't answer question number 1, but again, you know, I think it's open. Pradeep, Diogenes, Panda, Jenny, Kinsuda, any of you can still.
Rajul. Yeah. There you go.
All right, answer question 3. All right, let's see if this is going to change the... What is ASTRA DB? Simple. Is it a local in-memory version of Cassandra? Is it Cassandra as a service in the cloud? Is it an album by Radiohead? Maybe. Or is it a development tool? What do you get? Yeah, hopefully.
I think this one's an easy one.
Hopefully nobody gets this wrong, but we did. It is Cassandra as a service in the cloud. It's not a local in-memory version of Cassandra, and you know, it's definitely not a development tool. I mean, yeah, you know, maybe it is in a way. Yeah, but
maybe it was Stargate.
Really more of a Cassandra as a service in the cloud.
Yeah.
So let's see how the leaderboard is.
That's right.
I think there may be some shake-up, right? D-Jazz, Diogenes, and Jenny all jumped up. But again, anybody's game, because you know, we have not even reached the halfway point yet. And this might be the halfway point. Okay. Question 4 of 7?
I think so.
Answer fast, but most importantly, correctly. Uh-oh. This is the funny part. Leave page. Okay. Sorry about that. No, that was me.
Oh, what happened?
Yeah. So answer correctly. Which NoSQL database organizes data into tables with rows and columns? Is it relational? Is it tabular? Okay.
Oh, Rex, I think you need to maximize your window here.
I want to, because you know, then you can see the other answers. And so I'll just leave it like this. I think we're good. No. Yeah, let me
Gotcha.
go with
Good
this.
call. Good call.
Maximize this and see if that makes a difference. Okay, that's good. Yeah. So let's see how the leaderboard is going to shape up. I think there may be some changes again. Finsula might come up, maybe. Finsula is fastest. Finsuda, Jenny, Mridul, Daniel, Essay. You know, it could be really anybody.
Yeah, I know having relational databases there was a tricky one because it does organize rows into tables, but you know, it did say which NoSQL database.
Exactly.
So
there are the hints that you have to look into. There are still 3 more questions, so 5, 6, and 7. So anybody's game still. Answer fast. More importantly,
yeah, that's right.
Correctly. Which NoSQL database is better suited for finding the shortest path between entities in a network? I think Aaron talked about this quite a bit. Is it a traversal database? Is it a document database? Is it a graph, key value, or tabular? Again, is better suited, right? You could do it with any of them pretty much, but you know, what is better suited?
Which one values relationships?
And it is a graph database. It's really about entities, relationships, and trying to find kind of the shortest path, longest path, you know, and things like that, right? So complex.
You know, that's a good point. You know, we you know, I'm looking at the number of folks that got this one wrong, and I'm wondering if we should talk more about like some of the graph theory behind it, like you know, shortest path or an Euler path, or different types of traversals. So yeah, no, that's good.
I mean, the idea is you want to keep it a little tough, right? And kind of see how the leaderboard shapes up. Although, you know, some of you might not be very happy with this, but
Chimay on that one.
Finsuda did well, and you know, it could be anybody's game. Isabel, Lynn.
And the drool is coming back.
Yeah, still 2 more. So let's see how that goes. Good luck to those of you. Okay. Answer fast and correctly. What is the key value database? Should be easy, right? Supports complex relations and joins. Is perfect for simple key-based data retrieval. Is perfect for doing complex analytics. Yep. Always stores valuable cryptographic keys. I guess you could do that. Let's see. If anybody got this wrong, supports complex relations and giants. I think these are people who are frustrated with the you know, way things are going. But yes, is perfect for simple key-based data retrieval. And let's see how the leaderboard is shaping up. What happened there? I think we got some changes there. Jenny was the fastest. Yeah.
I think so, yeah.
And Finsuda still maintains the first place, although was not the fastest, right? Yeah, sometimes it might be, you know, it might take a moment
Jenny was the fastest.
to look at it, you know, especially if you got it wrong, because I think the problem with Menti is there's no way you can go back and correct it, right? So once you submit it, it's a little bit hard, and I have done it myself. But for all the marbles, the last question 7 of 7. Yes,
last one.
Go for it. Answer fast, but most importantly, correctly. What format does ASTRA DB use to store and retrieve documents? Is it tabular? Is it binary? Is it HTML? Is it XML, or is it JSON? I think I gave a hint there.
This I would think would be an easy one.
We'll see. All right, time's up. And most people got it right. Yeah, it is JSON. So here's what you're going to do. If you are in the top 3, you're going to take a screenshot of not, you know, the screenshot here, but the screenshot on your phone, and
Yep. Yeah, the one that says you're a winner.
And then you're going to submit that, and hopefully the slides are updated, you know, to kind of let us know which one it is. Okay, so the winner is, let us see, it's close. Ooh, Finsuda just maintains a slight lead, I think. Oh, 300 points. Yeah, maybe not slight, you know. But Chinmay, you know, gave a run for the money. Danielle, close enough. So the three of you, you're going to take a screenshot on your phone, okay, and you're going to submit it. But in the meantime, if you want, I can go back and put that in. Just let me on the chat. I'll put that back in just for a second, okay. Hopefully come back with the same result, right? So Finsuda was the winner, Chinmay second, and Danielle third. And congratulations to Finsuda, Chinmay, and Danielle. And hopefully you have taken a screenshot. Okay, and we'll talk about how to. But before you go away, there's a quick survey. What do you like the most? What do you think we should improve? And we'd be happy to kind of keep this going. If you like something, give us a thumbs up on YouTube, okay, and also let us know what we can do better, okay. All right. With that,
otherwise,
we are done with Menti.
I think in terms of we got done in a good amount of time considering the slow start.
Okay. So the swag winners, there you go. It's already updated. This is the beauty of kind of working in tandem, right? Thank you, Aaron, for doing this. Basically, what you're going to do is you're going to go to datastacks.io/workshop swag, include a screenshot of your Menti screen to claim your prize, okay? And again, congrats to the first, second, and third place winners. Don't answer and invite YouTube chat, but look at the phone and then you do your homework. To do your homework, it's all on the GitHub link. It talks about what you need to do. But basically, you complete the hands-on exercises, submit a form with your results, and you're going to get a badge. Okay, pretty straightforward. We don't make it too hard because we recognize that you guys are going to be busy. Let me stop the quiz music. We don't really, yeah.
Oh, that's a good idea.
All right, and I know.
Right, you're a busy guy.
Right, with that said, moving on. We do provide a certificate voucher. I think you can get this off of this QR code. Okay. So just go to datastacks.io workshop voucher and claim this. Okay. We are building up towards what is what we haven't done in a few years. Because of the pandemic and all that. But all signs point towards a great Cassandra summit. I think Aaron alluded to transactions. I think there are going to be quite a few sessions maybe about that.
There'll be some great speakers there, like from Apple and Netflix and Intel and a lot of other big companies that use Cassandra.
Especially the
for
Cassandra
sure.
Day is an early indicator of the Cassandra Summit. I just can't wait for this. So I really want to because I learned a lot myself. But we will have these workshops as well, but a little bit more advanced. You will have something on Cassandra, maybe something on data modeling. So you can get a lot more in the workshops as well. So mark your calendars and book your tickets to, this is a Linux Foundation event. So Linux Foundation is helping us organize this. So, please, mark your calendars. And most importantly, tell your friends, family, whoever wants to attend, right? Certifications, we have talked about this. There are different paths in the academy.datastacks.com. If you want more help, more in detail discussions, jump on Discord. We have, our YouTube channel. You can subscribe to it. We have almost close to 30,000 or maybe north of that, subscribers. So we're doing
Just
pretty
about
well on that.
Yeah.
But, we built it up one at a time. So we really want to, you to subscribe as well. And with that said, Aaron, do you want to say anything else?
I think we're good.
Or...
Right. Hey, just thanks everyone for coming out. I know, learning NoSQL databases can be pretty challenging, but I hope Regs and I have done a good job of showing you some easy ways to go about getting started. And yeah, like Greg said, if you have any questions, feel free to hit us up on Discord.
Yeah, and with
We're happy to
ASTRA,
help.
with the $25 credit, hope you can keep using it. And with that said, thank you all very much.
I think we're done.
And as always, don't forget to click that subscribe button and ring that bell to get notification.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.